In the previous video about mathematical preliminaries, we talked about propositions, sets, some operations on the sets, and some special sets. And now we are going to talk about some other operations on sets. So the first operation is union. Union. Let's suppose that you have two sets A, 1, 2, and another set B with an element 2, 3. So the union of the two sets contains all those elements which are either in A or in B. So A union B is defined as all such elements which are either in A or in B. So which means that A union B is equals to, since 1 is in A, so 1 is here, 2 is in A, so 2 is here, there is nothing else. So 2 is in A, 2 is in A union B, 3 is in B, so here 3. So A union B is defined as all such elements, the collection of all such elements which are either in A or in B. There's another operation called intersection. It contains all those elements which are both in A and B. So one is in A, but one is not in B. So one cannot be the part of uh, A intersection B. 2 is in A and 2 is also in B. So 2 can be a part of A intersection B. So there is nothing in A that is left out, but 3 is in B. But 3 is not in A, so 3 cannot be part of A intersection B. So A intersection B contains only 2, which is common to both the sets. We say that all such elements, all such elements which are both in A as well as in B, as well as, that is, and. This is represented and X is in B. The next one is complement. Complement of a set. So it requires only one set to be taken in the complement. But before actually taking complement, you need to know the larger set, the universal set, the set containing all those objects which are related to the problem. So there is something called universal set. Universal set that contains all the objects that are of interest in a problem. So let mostly we denote it by U, and the complement is generally refers to this universal set. So a complement of set A, complement of set A is is set of all items in U, but not in A. So for example, A is 1, 2, 3, and the universal set is the set of natural numbers. So 1, 2, 3, and so on and so forth. So A complement, which is denoted by A bar or A prime, it contains all the elements that are not in A but in U. So it does not contain 1, it does not contain 2, it does not contain 3, it will contain numbers from 4 and onwards, because 1, 2, 3 are in A. So they will not be the part of complement of A. Now, in sets, we know that we cannot have order. So sets do not have order, do not have order. Order means they the sets does not care about the order of items they are put in. Similarly, sets also requires unique elements. Sets need unique elements, so no duplicacy is allowed. Only item will be can be written in one time. So which means that if you write 123 or whether you write 312, all of them are equivalent sets. All of them are equivalent sets. And set needs unique items. So you cannot have duplicacy like 1, 1, 2, 3. So this is not allowed. This is not a set. So if we need such kind of things, such kind of things we want to discuss, we resort to sequences or tuples. What are sequences? So for example, you can assume or you can take the sequence of Fibonacci series. So 1, 1, 2, 3, 5, and so on and so forth. That's an infinite sequence. Infinite sequence because it has infinite number of elements and it also has an ordering. So first one will come, then one will come, then two will come, then three will come, and so on and so forth. And it can also repeat the things as many times as it likes. A tuple is a finite sequence. A tuple, so 1 to 1 is a tuple. It's a sequence also, but since it is finite, we can name it tuple. And generally, it's the number of items in a tuple. By that, we name it tree tuple or k tuple, corresponding to the number of items it has. So since it has three items, so we see name it tree tuple. Okay. So let's come to the Cartesian product. Cartesian product of two sets. Cartesian product. So this is the way we combine two sets. So it's the method to combine two sets. Let us suppose that you have a set A containing 1, 2, and there is another set B containing A and B. So all Cartesian product of A and B is denoted by A cross B, and it represents the items in pairs. The first item is coming from A and the second item is coming from B. So like 1A, 1B, all those items which is having this pair, they will come here. So 2, then A, and 2, then B. So you can also point out in sequences are written with the help of parentheses and sets are written with the help of curly braces. Okay, so again coming back to the Cartesian product is a set of sequences or set of tuples, and in this particular case, this is a set of two tuples. So every tuple is containing two items, two items, two items, two items. The first item is coming from set A and the second item is coming from set B. So that's a Cartesian product. You can define Cartesian product for more than two sets like A cross B cross C. However, in this particular case, first you do A cross B and then you can go ahead with taking a cross C. So for example, if you want to have another set C which is containing let's say X comma Y. So now A cross B cross C is the set of triplets, so three tuples. So the first item is coming from A, the second item is coming from B, and the third item is coming from C. Then again, so all such possibilities we cover. So 1B or 1AY, then 1 b x, 1 b y, and so on and so forth. So all such combinations will be here. So it's a set of three tuples. In the next video, we'll be going to talk about functions and maybe some graphs. Thank you.